Hello friends, today I am going to do the quick revision or one shot revision of semiconductor devices, which is useful for competitive examination, because in this chapter there are a lot of formulas that we have to learn, and that formulas which are useful for solving many numerical questions. Okay, now this particular revision I have divided into some different subtopics, in which first I am taking semiconductor physics. Okay, so first is types of semiconductor that I am going to discuss. We know that there are two types of semiconductor: intrinsic and extrinsic. Intrinsic semiconductor is the purest form of semiconductor, and extrinsic semiconductor is the impure form of semiconductor. For more clarification, you refer my video which I have prepared before covering the syllabus of 12th standard of semiconductor devices, in which first video was the one shot revision of semiconductor devices based on 11th portion. Clear? In that video I explain thoroughly what is meant by semiconductor. In this video I am taking the glance or glimpse of that particular chapter in context of competitive, or some important formulas and some quick facts that I am going to revise. Clear? Okay. So types of semiconductors are intrinsic and extrinsic semiconductor. Now if you consider intrinsic semiconductor, then in intrinsic semiconductor, electron concentration is equal to hole concentration. That's why this is called as intrinsic carrier concentration. And in semiconductor, two types of charge carriers are present: electrons as well as holes. Clear? Okay. Now intrinsic carrier concentration, Ni is equal to AT raised to 3 by 2 e raised to minus Eg upon 2 kT. Clear? So this is an important formula that we have to remember. Ni intrinsic concentration is A T raised to 3 by 2 e raised to minus Eg upon 2 kT. Now in this formula, if we observe, this Ni is called intrinsic carrier concentration. This A is constant, which is independent of what? Temperature. It is dependent on doping. Now this Eg is called as band gap, energy band gap, and this K is called as Boltzmann constant, and this T is a absolute temperature. Clear? Okay. So this formula that we have to remember. Now second important formula is Eg, which is Eg0 minus beta T. This is a formula for energy band gap of a material at any temperature. It means from this formula it has been observed that energy band gap is inversely proportional to temperature. As the temperature increases, energy band gap decreases, because as temperature increases, this factor will increase, so this subtraction becomes decreases. Clear? Okay. Then important formulas which are very important from your JEE and NEET point of view, in which one questions you will find in the paper based on conductivity and resistivity of material. So this conductivity of intrinsic semiconductor is sigma, which is equal to Ni, that is the intrinsic carrier concentration, into bracket mu p into Qp plus mu n into Qn, where mu p is the mobility of holes, Qp is the charge on holes, mu n is the mobility of electrons, and Qn is the charge on electrons. Mobility indicates at what speed the charge carriers will move inside the semiconductor material. Clear? So this is the formula for conductivity. Okay. Then unit of conductivity is what? Unit of conductivity is 1 upon ohm meter or Siemens per meter. Now second important is what? Resistivity of that intrinsic material, which is reciprocal of conductivity. So you have to only reciprocate this formula to get rho. Clear? Okay. Now applied electric field, suppose there is a one semiconductor, suppose this is a semiconductor piece, intrinsic, I have applied some voltage across it, okay, so that particular length is L of this conductor and voltage is V. So applied electric field is applied potential difference is equal to length of that semiconductor specimen, okay, V by L, which is equal to VE by mu n. Actually this VE means what? It is called a drift velocity. Okay, because drift velocity VE or VD is equal to mu times E. So VE by mu E or VH by mu P. Why VH? Because it is a drift velocity for holes. This is a drift velocity for electrons. Clear? So in this way, I have told you three important formulas. First one is what? Conductivity. Second one is resistivity. Then electric field in terms of potential difference and length, and electric field in terms of drift velocity and mobility. Clear? Okay. Next important fact is what? At room temperature, mobility of electron is always greater than mobility of holes. So mu n is greater than mu p. It means electron current is greater than hole current. What is the reason behind this? Because mass of electron is less. That's why the mobility of electron is more. Electron is more movable than holes because mass of electron is less. Okay, that's why electron current is greater than hole current, and total current in any semiconductor is the summation of electron current plus hole current, which is In plus Ip. Clear? So this is the important formula for total current inside the semiconductor material. Now if we observe extrinsic semiconductor, then there are basically two types, in which first is N type, second one is P type. So in N type semiconductors, as I already discussed with you, the important dopants which we are using is what? Pentavalent impurity, that is phosphorus, arsenic, bismuth. Clear? And in P type semiconductor, the dopant which we have used, that is trivalent impurities. Okay, that is boron, indium or gallium. These are the trivalent impurities. So majority carrier concentration in N type semiconductor is denoted by Nn. Means what? Nn means electron concentration in N type, which is approximately equal to donor concentration, because we are adding dopants and which results into donor atoms. So that Nn is equal to Nd for N type. So hole concentration in that N type material is given by approximately Ni square by Nd, where Ni is intrinsic carrier concentration and its value is what? 1.5 into 10 raised to 10 for silicon, and for germanium it is 1.5 into 10 raised to 30. That facts you have to remember. So this is what Ni square upon Nd. It is a hole concentration in N type semiconductor. Then conductivity formula for N type semiconductor is approximately equal to Q times, that is charge on that particular electron, into mobility of electron into donor concentration. Then the resistivity of the N type semiconductor is 1 upon conductivity, and total conductivity of the semiconductor is addition of N type conductivity plus P type conductivity, which is equal to Q into bracket mu n into Nd plus mu p into what? Na. Clear? This is a formula for total conductivity. Then for P type semiconductor, hole concentration is majority, that is Pp is Na. Then electron concentration in P type is what? Ni square by Na. Then conductivity of P type is what? Q into mu p into Na, and resistivity is what? 1 upon sigma. Clear? So these formulas are very important from competitive point of view, because in previous papers there are questions based on this resistivity and conductivity, and in that also they have specifically mentioned you ignore the hole concentration for N type. It means you have to only directly use this formula for conductivity, and you have to take the reciprocal of that and you will get resistivity. So in one paper there is a question on resistivity, determination of resistivity from conductivity for heavily doped N type. It means you have to ignore the hole concentration, only electron part you have to take. It means only these formulas you have to use. So this is the important formulas. Clear? Okay. Now another important formula, that is drift velocity, that is current density J is I upon E. Okay, which is equal to sigma total into E. J is sigma E. Clear? J is equal to sigma E. For N type it is sigma N into E, which is equal to sigma into electric field is what? V by L. So this is a sigma T into V by L. So any one of these formula can be utilized as per the requirement and data given in the problem. Okay, yes. Next is drift velocity Vd is equal to I upon NEA. This is also important formula. Drift velocity is equal to I upon NEA, and this is denoted by Vd. Now drift velocity can also be written as mu times E, mobility times electric field intensity, and this current density J can also be written as rho times Vd. Okay, where rho is a charge density and charge density is given by charge per unit volume, which is coulomb per meter, that is N into E. So N is not number of electrons or holes or number of charge carriers, it is carrier concentration. It means per meter cube. You have been given in per meter cube. That's why coulomb per meter cube. Clear? So J is equal to sigma E, J is equal to rho V, where rho is not resistivity, it is a charge density N into E, and N is concentration, which is in per meter cube into coulomb. Oh, so which is coulomb per meter cube. And finally what? Rho is equal to Ne and J is equal to rho Vd. Then Vd is I upon NEA. So these are the important formulas from semiconductor physics which can be utilized while solving the problem in JEE and NEET. And you will find one question from these formulas. So please prepare this formula very well. Clear? Okay. Now I am going towards PN junction diode. This is also one of the important part in your JEE exams. Okay, or NEET exam. You will be given some circuits and you have to model diode with equivalent circuit, and then you have to calculate some quantities. Clear? Listen here. Suppose in PN junction diode there are two methods of biasing, forward biasing and reverse biasing. So in this biasing, forward biasing, this diode D is connected in forward bias, as anode is more positive than cathode. Then RS is the series resistance or source resistance and RL is the load resistance. If diode is ideal and if it is made up of silicon, clear? If it is ideal, then directly, and if it is in forward bias, then I have to make diode short circuit. If it is forward bias and ideal, short circuit. If diode is practical and it is made up of silicon and forward resistance of diode is 0, it means even though diode is forward bias, it offers some opposition. It means what? It offers some resistance. That forward resistance is 0, I am assuming. Then replace this diode with 0.7 volt battery for silicon. If diode is practical and forward resistance is not equal to 0, then replace that diode with 0.7 battery with series resistance, that is forward resistance. Clear? Okay. So replace this diode with battery 0.7 and forward resistance RF. So this is important. This diode in this circuit is replaced with this circuit, that is battery 0.7 along with RF forward resistance, if it is practical and forward resistance is given. So in this way, if you want to find out the circuit in the if you want to find out the current in the circuit, then you can find out I is equal to V minus 0.7 upon RS plus RL plus RF. In the problem actually RS is not given, but I have given you. If all the factors are given, then also you can solve the problem. Clear? And another important point, you cannot directly apply the Ohm's law because diode is non-ohmic device. That's why you have to replace the diode with linear devices, that is resistance. So in this way you have replaced the diode with the linear component and then apply Ohm's law. Okay, so this is called as modeling of diode. Replacing a diode with 0.7 volt, replacing a diode with short circuit for ideal, replacing a diode with 0.7 along with series resistance, that is forward resistance, if it is given. Clear? So this is important in case of forward biasing. If you consider reverse biasing of diode, same circuit can be connected, but positive terminal is now connected to cathode, means cathode is more positive than anode, that is a reverse bias. If diode is ideal one, then in reverse bias it acts as open circuit. That's why current in reverse bias is 0, because diode is open. Now if diode is practical, it means what? It does not act like a open circuit, but it acts like a what? The battery of what? The applied voltage, reverse voltage or breakdown voltage. Clear? And if diode is practical and it offers some resistance, practical means what? Practically any diode in reverse bias offers infinity resistance, but in practical it offers some high value resistance which is in mega ohms. That's why this RZ should be connected in series with this voltage VZ. So replacing your diode whenever it is in reverse bias, open circuit ideal, replacing with the battery of voltage VZ ideal without RZ, and replacing with battery and RZ if RZ is given in the problem. So you have to understand all these three important parts which I have explained to you. Okay, first one is semiconductor physics, second one is what? PN junction diode in forward and reverse bias, because these are very, very important for your competitive exams. Okay, now we are going to discuss Zener diode as a voltage regulator, which is also one of the important subtopic in competitive exams. One question is definitely come in JEE as well as NEET. Okay, so Zener diode is one of the important repeatedly asked topic in the competitive exams. Listen here, in this Zener diode, if you observe, this circuit is actually popular because Zener diode is always connected in reverse bias. That already we have known. So this Zener diode is reverse bias and Zener voltage is Vz of this diode. This Rs is the current limiting resistor and this RL is the load resistance of what particular load which we are interested to connect, and this Vs is the source voltage, and this is the characteristics of Zener diode. This particular portion in which Zener diode is operating, this is called as breakdown region, and this voltage is Zener voltage. So this is the minimum Zener current which is also called as knee current, and this is the maximum Zener current which is Iz max. So your Zener diode should operate from Iz minimum to Iz maximum. Clear? And Zener resistance Rz is equal to delta Vz by delta Iz. Clear? Okay. Now important part is what? Regulation. On types of regulation you will find question in the examination. So there are two types of regulation in Zener diode, that is load regulation and line regulation. So load regulation means what? Whenever there is a variation in the load, that time RL is variable, then this is called load regulation. And whenever this input Vs, which is source voltage, when this is variable, that time it is called as what? Line regulation. Clear? Okay. Now whenever we are considering load regulation, that time first is what? Load is variable and source is fixed. So Is, which is a source current, that is fixed, which is equal to what? Vs minus Vz by Rs. Is. Then if Is is fixed, then what happens actually? There is a division of current, but Is is divided into two currents, Iz and Il. Clear? So Is fixed is equal to Iz plus Il. It is a basic formula. If Is fixed and load RL, if it takes value maximum, RL is maximum, it means load current is minimum. If this load resistance is having maximum value, then load current is minimum value. So that time this IL is minimum. So this Is fix is equal to Iz maximum plus IL minimum, and Is fix is equal to Iz minimum plus IL maximum. It means if this current through load decreases, Zener diode current increases, so that overall current is constant. Okay, so in this way Zener diode acts as a load regulator. So you have to remember these two formulas for load regulation. Is is Vs minus Vz by Rs, Is fix is Iz max plus IL min, and Is fix is equal to Iz min plus IL max, where IL min is equal to what? Vz by RL max, and IL max is equal to means what? Vz by RL mean, because this is a Vz, this is which is across the load. If it is regulator, then load is current flowing through this is what? IL is Vz by RL. So if this is RL is minimum, then this is current is maximum. If this is maximum, current is minimum. Clear? Okay. Then important is what? Line regulation. So in line regulation, Vs is variable, source is variable. So if source is variable, then Is minimum is what? Vs minimum minus Vz upon Rs. Clear? Because if Is to be minimum, then Vs should be minimum. If Is to be maximum, then Vs should be maximum. So Is maximum is Vs max minus Vz by Rs. Clear? Okay. Then this is a basic equation. In load regulation, this Is is fixed because input voltage is not changing, but here input voltage is changing, so Is is variable. Now Is minimum is equal to Iz minimum plus IL fix. Why this is Iz minimum plus IL fix? Because if Is is minimum, then Iz has to be minimum, then only the IL becomes fixed. So if this current is fixed and if it is increasing, then it has to, Zener current has to increase. If it is decreasing, Zener current has to decrease. Means what? Iz maximum to Iz minimum. That's why in this portion your Zener diode should operate. So Is maximum is Iz maximum plus IL fix, and Is min is equal to Iz minimum plus IL fix, and load current IL fix is Vz by RL. So in this case there is no any maximum or minimum load current because load is fixed. Okay, yes. Now power, this is also important because in examination you will find a question related with power and Zener current. So power dissipation in the Zener diode, that is Pz minimum, is equal to Vz into Iz minimum. Okay, this is Vz into Iz minimum, and Pz maximum is Vz into Iz maximum. Since Vz into Iz maximum, that is Pz maximum power dissipation in the Zener diode, this is called as minimum power rating of Zener diode. Okay, many times students are confused. They means minimum power rating means they calculate Pz min. No, minimum power rating means what maximum power means. This is a limit beyond which you cannot operate. This is a restriction to operate the Zener diode beyond Iz max. Clear? So that's why this Pz max is Vz into Iz max. This is called minimum power rating. Minimum power rating means Pz max only, and minimum power dissipation means Pz minimum. Clear? So this is an important point. Then when Zener diode is in breakdown region, then what happens? It is replaced with what? It is replaced with its breakdown voltage Vz, so that V0 is equal to Vz, because output remains constant. And if Zener diode is in breakdown region, and if it is not ideal Zener diode, in that case there is a voltage drop Iz into Rz. That's why we know V0 is Vz plus Iz Rz if Rz is not equal to 0. Clear? Okay. So in this way, this Zener diode is replaced with Vz if it is ideal. If it is practical, then it is replaced with Vz and Rz, where Rz is the Zener resistance connected in series with Zener diode. If this is a non-breakdown region, in that case this Zener diode acts as an open circuit whenever it is reverse bias, and if it is practical, then it is replaced with Rz. Clear? So you have to remember these two types of regulation and its related formula for what? For IL minimum, IL maximum, Is fix, Is minimum, Is maximum, then what? Power dissipation in the Zener diode. That formulas we have to remember. Clear? Because in Zener diode you will find such kind of figure, and you have to calculate the unknown current or any power dissipation calculation that you have to solve for that particular unknown application or unknown parameter. Clear? So this is the application of Zener diode as a voltage regulator. Now we are going to discuss another important subtopic from these semiconductor devices, which transistor as an amplifier. It is also one of the important topic from exam point of view. You will find one question from it. This transistor as an amplifier, as I already discussed with you in the regular core lecture, amplifier means increasing the strength of the signal. So if this is the input signal, then this is the amplified signal. It means its magnitude, amplitude is increased, but shape is same as that of original signal. And from exam point of view, this is the basic circuit diagram of amplifier which is provided in the question. Clear? Now important is what? Some formulas that you have to remember while solving the questions. Whenever you observe such kind of diagram, then what parameters you are supposed to calculate, that I am going to discuss. This is the important first equation. VCC is equal to VCE plus ICRL. From where this formula comes or equation comes? If you consider output side and apply the Kirchhoff's voltage law, then VCC, this applied voltage or supply voltage, is utilized VCE plus ICRL. It means what? VCE means voltage drop across this particular particular transistor, that is a voltage drop between collector to emitter. And ICRL, it means what? This is a load resistance. So applied voltage is utilized in can be spent for two purposes. First, it is a voltage drop across collector to emitter. Second part is voltage drop across load. That's why VCC is VCE plus ICRL. Clear? Then input Vs is equal to Vb, input Vs is equal to Vb is equal to delta IB Ri. It means as per Ohm's law, change in input current into input AC equivalent resistance result into input. Then there is another important beta AC, current gain of transistor, that is delta IC upon delta IB. Then voltage gain of transistor, whenever it is operating as amplifier, it provides gain, output voltage upon input voltage, which is equal to minus beta AC RL by Ri. It means, or it can be written as current gain into resistance gain. Gain means what? Output by input. Output side which is resistance present, load resistance. Input side which resistance present, Ri. So ratio of these two means what? Current gain. So that's why this is current gain into resistance gain, RL by Ri. And minus sign indicates what? there is a phase shift between output and input of an amplifier by 180 degree. This is important one. These questions one time asked in the examination. What is the phase difference present between output and input of common emitter amplifier? 180 degree. Phase difference means if input is like this, you are getting output like this. This is called phase difference. Clear? This is a phase difference. The output is what? Lagging with respect to input by 180 degree phase shift. This is an important statement. Then IB, that is what? Base current. Base current is Vs minus Vb upon Rb. Vs minus Vb upon Rb, because these formulas can be utilized for solving the problems, or whenever we we want to find out Rb, then we can use this formula. So you have to remember basic this first formula. VCC is equal to VCE plus ICRL. Beta AC is delta AC by delta IB. Voltage gain is beta AC RL by RI, and IB is equal to Vs minus Vb by Rb. These are the basic formulas which are important in case of this transistor as an amplifier in common emitter. Now there is another important what we can say configuration of transistor, that is common base and common emitter. So in common base and common emitter, I have prepared table so that it is easy to understand. This current gain alpha is delta IC by delta IE in case of common base, which is current gain beta in common emitter, that is delta IC by delta IB. Then voltage gain AV is equal to delta VO by delta VI, that is AV is alpha AC RL by RI in common base. In common emitter, it is AV is equal to minus beta AC RL by RI. Okay, so this is actually minus sign, minus beta AC RL by RI, because on these formulas many times question have been asked in JEE. Okay, you have to find out voltage gain or power gain. Clear? So this is important. Next is power gain. Power gain is what? Alpha AC square RL by RI in common base. In common emitter, it is beta square RL by RI minus beta square RL by RI, and RI is equal to delta VI by delta IB. Here RI is delta VI upon delta IB. So these important facts that you have to remember in case of transistor as an amplifier. Also, one of the important relation that you may know, alpha is equal to beta upon beta plus 1, and we can say beta is equal to alpha upon 1 minus alpha. So these are the two important relations that you should know. Beta is alpha upon 1 minus alpha, and alpha is beta upon beta plus 1. So as a transistor, in transistor as an amplifier, you should know all these formulas, especially voltage gain, current gain, power gain, input resistance. Clear? And formulas for formulas for KVL, that is VCC, then Vs and IB. Okay, and VB you have to write 0.7 volt for silicon transistor. Clear? So from transistor as an amplifier point of view, you have to understand all these formulas so that you can solve the question based on transistor as an amplifier. Clear? So in this way, in this lecture, we have completed the one short revision of semiconductor devices, in which first part was semiconductor physics. Afterwards I discussed with you diodes, that is PN junction diode for in forward bias, reverse bias, and its modeling. Then Zener diode as a regulator, which is also one of the important topic. That in that case I discussed with you the regulator application of Zener diode. And finally transistor as an amplifier, which is an important topic from your JEE point of view, in which one question you may find in your paper. Clear? So in this way you prepare all these formulas from semiconductor devices, because so that you can handle every question comfortably without any hesitation. Thank you.